What you see on the screen is an Instec GSP 730 spectrum analyzer doing a measurement of ACPR, that is, adjacent channel power ratio. Don't worry if you aren't really up to speed on this yet. We'll look over what this really is and why we measure it and so on in a little bit. But I wanted to do this video, and Richard, you know this one's for you. You had asked earlier in the semester if I could go over this, and so I'm finally getting around to it, and I apologize for the delay. But you said if I could get it done by the summer, that you would be happy. So I'm hoping that this will still be useful to you. If not, I apologize, but for anyone else who might be interested, I thought I might go ahead and post it on YouTube. Now, I've done these measurements before in some other YouTube videos, and in fact, that was where the student that asked about this saw them, but he wanted a little more explanation, particularly because he was using the Rigol DSA 815. And so his specific request was, could I show how to do the same measurements on the Rigol? And I will do that in due course. But I thought I would review what we're actually doing here. You see at the top the spectrum of the signal. Now this is an ordinary FM signal with a carrier frequency of 880 megahertz approximately, and a deviation of approximately 2 megahertz, that is plus and minus 1 megahertz from that 880. And the specifics of this come from the Instec training manual that comes with the GSP 730 and GRF 1300 training system, which we'll go over in a little bit. But basically, the channel bandwidth is 2 megahertz, and the channels are spaced 5 megahertz apart. The adjacent channel bandwidth, 1, is 0.8, and the offset is 2 megahertz. The channel bandwidth 2 is 0.5, and the offset is 4 megahertz. And notice what we're reading. Channel power of about 6 dBm, and a lower adjacent channel power ratio of around 43, and an upper of around 44 dB down. The second is minus about 47, and similarly for the upper is about minus 47. So what do all these numbers mean? How did we measure this? And then how would we do this on another spectrum analyzer? I'm going to try to explain what it is we're measuring and why with this diagram. Now, what you see here is a waveform, or a spectrum actually, and then each of these lines defines a channel. The main channel is the channel that we want, that we're most interested in. That's the channel that we are using. That could be, for example, with a cell phone, that could be the active channel for a particular cell phone transmitter, something of that sort. On each side of the main channel are often adjacent channels. The ones that are higher in frequency are generally called the upper adjacent channels, and the ones lower in frequency, of course, the lower adjacent channels. This dotted line represents the carrier of the main channel. This dotted line represents the carrier of the upper adjacent channel. The spacing between these carriers is the channel spacing. Now, it's the channel spacing of the next channel. So, The main channels might be spaced differently from the adjacent channels for various reasons. It has to do with what these adjacent channels are being used for. Sometimes these adjacent channels are used for what are called subcarrier applications. In other words, they may be transmitting data that is unrelated to the basic communications and so on. But one way to think of this is, in, for example, the GSM band, the channel spacing is uniform at 30 kilohertz. So, but they're not always that way. And the particular example that INSTEC has in their training manual, these bandwidths are not the same. The main channel bandwidth is plus and minus 1 megahertz. The adjacent channel bandwidth is 0.8 megahertz, and the next adjacent channel bandwidth is 0.5. And they do that so that you'll understand these do not have to necessarily be uniformly spaced channels. And Richard, here is where I think you were having some problems. I think what you were confusing was the resolution bandwidth with the integration bandwidth. Let me explain what those are. What we're trying to do is to measure the power in each of these channels. So we want to know the power in the main channel, the power in the upper adjacent channel, the power in the next upper adjacent channel, and so on, as well as the lower channels. But we're trying to measure power. To do that, we integrate the power over the channel bandwidth, and that is what is called the integration bandwidth. In other words, normally it's the same as the channel bandwidth. Similarly, the integration bandwidth for this channel is only 0.8 megahertz, not 2 megahertz. But those are quite distinct from the resolution bandwidth that you are using. Resolution bandwidth is how you have the spectrum analyzer set. It determines how crisply you can measure the values of the power spectrum. Normally, you want quite a few bins or slices in order to get good resolution. INSTEC recommends that the resolution bandwidth be no bigger than 5% of the channel you're trying to measure. Or another way to put that is, using the reciprocal, they would like there to be at least 20 bins across each channel that you're measuring so that you get pretty good resolution. But the resolution bandwidth and the integration bandwidth are not related in any way. You can use any resolution bandwidth you want. If you use too wide a resolution bandwidth, your resolution will suffer. But you could use less than the recommended resolution bandwidth if you wanted to, or more. It's just that the narrower the resolution bandwidth, the better the resolution, and therefore the more accurate the results you'll get. Okay, so that's what we are trying to measure, is how much power is in this channel compared to the main channel, and also how much in this channel, and also this channel and this channel. And the INSTEC experiment, you measure the main channel and 4 adjacent channels, 2 above and 2 below. So how do we set this up on first the INSTEC? I'm going to assume that you already know how to set up the basic spectrum analyzer, the center frequency, the span, the resolution bandwidth. In this case, we're just using the auto resolution bandwidth, which it turns out at this frequency is a megahertz. It's an 880 megahertz carrier, and we have plus and minus 5 megahertz, so a total of 10 megahertz on the screen. In other words, this is the carrier plus 5 megahertz, and this is the carrier minus 5 megahertz. So how do we set this up? Well, the first thing we do is we enter the measurement mode. And from here on, I won't keep moving the camera over to this side. I will assume that you know how to do those adjustments. And I will call your attention to the bottom of the screen in the lower left-hand corner here in a minute. So we have the measurement menu up. Notice it says measurement at the top there. And we want to turn on ACPR, Adjacent Channel Power Ratio. And by the way, sometimes this is called Adjacent Channel Leakage Power, or ACLP, in some textbooks and in some instruction manuals. So we're going to turn ACPR on. We touch this button, and that selects this button. It doesn't turn it on. You have to press it again. This is a peculiarity of the Instec. You have to press it again to turn it on. And you notice that the screen then divides into two sections. Then you go up to the channel setup and you press that. And once again, you have to press channel setup twice. You'll notice now that three windows: main channel bandwidth, main channel space, and ACPR setup. Now, main channel bandwidth, remember, is 2 megahertz. So we select that, and you'll notice down in the lower left-hand corner, it says channel bandwidth. And we want 2 megahertz. And you'll notice it reads it there, 2 megahertz. Then we want the main channel spacing, which in this particular case is 5 megahertz. So we enter 5 megahertz, and you notice down here it says channel space 5. Then we enter the ACPR setup. So in other words, you're just going down through these function keys. And when you press that, a new set of menus appear. The first is the adjacent channel bandwidth. The next is the adjacent channel offset, or spacing, and that's from the main channel. Then if the second adjacent channel, now this is not the upper and lower, this is this is the adjacent channel bandwidth for both the upper adjacent and lower adjacent. The bandwidths have to be the same. So back on this display, if this is the main channel, what we are doing is setting the bandwidth of this next channel up and of this next channel down. So let's enter adjacent channel bandwidth, and notice that in the lower left-hand corner it says adjacent channel bandwidth, and we want 0.8 megahertz. Now we go to the next one, the offset. Notice it shows us the offset, and I've already set this up, so the figures are already there. If you were working with a different channel spacing or bandwidth, obviously these numbers would change. So it's 2 megahertz, so we enter 2 megahertz, and you'll notice we read 2 megahertz down here. Then we go to bandwidth of channel 2, and it is 0.5 megahertz. We've entered that, and then we enter the offset for channel 2, which is 4 megahertz. And you see we get 4 megahertz. Now, displayed on the left are the figures we just entered: the main channel bandwidth and spacing, the adjacent channel 1 bandwidth and offset, the adjacent channel 2 bandwidth and offset. up here are the measured values. It says the channel power, that means the main channel power, is about 6 dBm. The lower adjacent channel power ratio for channel 1, I wish they would note that this top row is for channel 1 and the next row is for channel 2. So this LACPR is 43, approximately minus 43, and this is approximately minus 44. At least that's what I'm going to write down. The second adjacent channel is minus 47 and about minus 47. So that's what I'm going to write down. So once again, this is the main power. This is the power ratio of channel 1, both upper and lower, and this is the power ratio of channel 2, both upper and lower. So now we have completed the measurement of ACPR using the Instec GSP 730. Now we have set up the same thing on the Rigol DSA 815. The display of the Rigol is a little more intuitive than the Instec because it shows you in blue what your main channel is. And in this case, we're offset just a little bit. Notice that the point where it crosses here, it was true of the other measurement as well. But the lower, the spectrum on the low side crosses the bandwidth at a lower level than on the high frequency side. But the blue is the main channel, and then over here is the upper adjacent channel, and over here is the lower adjacent channel. So how did we set that up? Well, the first thing we did, I'm going to turn off the measurement now. And we're back to our basic waveform, which, by the way, I haven't changed it. This is exactly the same signal with approximately 2 megahertz, plus and minus 1, that is, around an 880 megahertz carrier. This is FM. So the way that we set this up, let me move this over just a little bit. Well, no, let me just zoom out a little. And the way this is set up is you turn on measurements, and you'll notice that it shows you the measure menu up here, just like the Instec. But here it says measurement function, and it says off. If you press that, a new menu will come up with off, total power, adjacent channel power, occupied bandwidth, and so on. We want adjacent channel power, so we press that one. And notice once again the screen divides into a spectrum at the top and a display window at the bottom with data in the window. Then we go to Measurement Setup and press that. And the ACP Measurement Setup window comes up. Watch for ACP at the top. You can average if you want. We're not going to do that. We're just going to leave it in the normal mode. Then we press Main Channel Bandwidth, and we set that to 2 megahertz. We then press Adjacent Channel Bandwidth, and we set that to 0.8 megahertz or 800 kilohertz. We then set the channel spacing, and understand this is the spacing of the adjacent channel, to 2 megahertz, so that we get exactly the same relative measures that we got earlier. And you will notice that with the main channel power, that is the power within this blue region, it reads minus 5.9, which is very close to the minus 6 we were getting with the Instec. But the upper and lower channel power ratios are reading about minus 60 dBm, whereas in the Instec we got about minus 43 or 44. Why the difference? Well, the main difference is that we are using a different resolution bandwidth. So let's go to a resolution bandwidth of 1 megahertz that we were getting before. And you notice now, and this is what I was talking about, especially for you, Richard, because you were having issues with this. This is a little bit difficult to to explain, but the Instec compensates for the fact that it uses a fairly coarse resolution bandwidth. And so, to get comparable results with the DSA-815, you have to set your resolution bandwidth to at least 300 kilohertz, and preferably 100 kilohertz. You'll notice there, we're starting to get the same main channel power. The Instec compensates for the lack of resolution at a megahertz, and it's done in the software. And the reason is that the Instec was originally designed to be used for measurements in the GSM band. It's optimized for 30 kilohertz bandwidth. It's optimized for 800 to 900 megahertz on its frequency, and so on. And so it is a little bit of a compromise instrument compared to the DSA-815. If you use, and that's why I went into the issue at the very beginning, of the relationship between the resolution bandwidth and the resolution that you get in the final results, you will find that you want to go ahead and use the auto setting of the Rigol. And the auto setting of the Rigol at this setup is 100 kilohertz resolution bandwidth, whereas the auto setting of the Instec is a megahertz. The Instec compensates for that. The Rigol measures it correctly. So these are actually the figures you should be getting from the upper and lower sideband power ratio. But the purpose of this video was not to show you how to get exact readings, because there are some issues to that as well, but mainly to show you why you were getting completely different readings with your Rigol than we got on the Instec. And it all has to do with this resolution bandwidth being different and the fact that the Instec tends to compensate for it. So I hope this is useful to people who may have watched some of the earlier videos. The ones that I was referring to are my numbers 52, 54, 56, and 76. You see them there. And there's also a playlist that incorporates those four plus an extra one. But basically what we have been trying to do is to talk about how you do ACPR measurements and why resolution bandwidth makes such an important difference in the results you get. The narrower the resolution bandwidth, the more precise your results are, assuming everything else is equal. In other words, assuming that the instrument is properly calibrated and you're using it correctly. As you lower the resolution bandwidth, you get more precise measurement results. So I hope this has been useful. If it hasn't been too useful to you, I hope at least you were entertained by it. And I hope you look forward to maybe some more, although I don't think I'm going to do any more in this area. I could do one on occupied bandwidth, but I think that's pretty well understood. Basically, it's equivalent to what we measured here in terms of the main channel power. But let's not go there. At any rate, thanks for watching, and have a nice day.